Today I'll be doing RIP protocol. RIP protocol, which is also known as Routing Information Protocol, is an example of distant vector protocol. And distant vector protocol is an example of dynamic routing. And RIP determines its routes based on hop count. In RIP, routers periodically exchange their routing tables with the neighbor routers. RIP use hop counts only to determine the shortest path to a destination. So if you are sending packet from one router to another router, it will find the shortest route, shortest path to send that packet. To avoid loops, RIP limits its path to a maximum of 15 hops, which make it ineffective protocol for the large networks, which means you cannot add more than 16 routers in the RIP protocol. Let's understand RIP in more details. Let's take the first option, where when data packets forwarded to a network segment, it is counted as a single hop, which means if router 1 sends packets to router 2, then it will be counted as the first hop. When router 2 sends data to router 3, it will be counted as second hop. And when router 3 sends data to router 4, it will be counted as third hop. So here is another option that it says it will check for possible hops to send the data. Let's take an example. If router 1 has to send data to router 4, then it have 3 possible routes: route 1, route 2 and route 3. If it select route 1, then it has to go through 3 hops. If it choose route 3, it has to go through 4 hops. You can see here first hop, second hop, third hop and 4 hop. If it choose route 2, then it has to go through 2 hop. First hop and then second hop. Only 2 hop. RIP protocol, router always choose the shortest path based on the hop count. So in that case, if router 1 has to send data to router 4, then it will choose route 2 to send the data, because this is the shortest path based on the hop count. Next option we have is if hop count is same, it use both route using load balancing. So packets reach destination faster, which means let's take an example. If we have one more router here, then this route and this route will be same. This route also will have 3 hop and this route also will have 3 hop. So in that case, router 1 choose both the route to send the packet by using the load balancing, so that router 1 can quickly send the packet to the router 4. Let's take another scenario. If there is a heavy traffic in route, you can see route 2 have a heavy traffic here, and let's say router 1 have no traffic and have a better bandwidth. Even in that case, router 1 is not going to choose route 1. It will only choose route 2 because it work in the hop counts only to send the packets. So this is the one of the disadvantage of the RIP protocol. Let's go to Cisco Lab and then create a topology to configure RIP protocol. Let me take a router. I'm gonna take PT router because it already have a serial port in it, so I don't need to go to each router and add serial port. I'll take one PC and then 2 switch. Now let me connect all these devices. First I'm gonna connect routers with serial DC. You can see I have connected all these devices, and I'm gonna assign this network 70.network to fast Ethernet, and then 10.network to serial port 2/0, 20 network to serial 3/0, and then 30 network to serial 3/0, 40 network to serial 3/0 of router 2, and then 60 network to the fast Ethernet of the router. And now let's go to router 0 and assign IP and turn on the port in this router. This is in my router. Enable config T configuration mode, and then so let's assign 10.network to the serial port 2/0. So you need to go to the interface. Yes, E 2/0, and then we have to add the 10.network, which is IP address, which is IP address 10.0.0.1 and subnet mask 255.0.0.0. So as you can see, here is a clock, which means this is the DC side of the cable, so you need to assign the clock rate as well. Clock rate, I'm gonna give 64,000, and then you need to just simply type no shutdown to turn on the port. So this is how you turn on the port, and you need to add IP to the serial IP to the next port, which is serial 3/0. So let's do exit and then enter to the serial 3/0. Assign IP address. This is a 20.network, so I'm gonna assign the IP 20.0.0.1 with subnet mask to 55.0.0.0, and then no shutdown. So you can see router 0 is also connected with the fast Ethernet, so you need to assign IP to that fast Ethernet as well. Fast Ethernet 0/0 IP address, which is 70.network, so I'm gonna write 70.0.0.1 and 255.0.0.0, and no shutdown. You can see the port is green now. So this is how you assign IP and turn on the port. So all the configuration is done in router 1. You can go to router 1 now. You can go to second router. No. And then enable mode, config mode. You can see router 1 is connected with the serial 2/0. So I'm gonna enter to serial 2/0, and I'm gonna assign IP address. Since this is the 10.network and I already have assigned IP 10.0.0.1, so here I'm gonna assign 10.0.0.2 with subnet mask 255.0.0.0. You don't need to assign any clock rate because this is the DT side of the cable, so you just need to write no shutdown. So this state is up now, so I'm gonna exit, and you can see router 1 is also connected with the another router through the serial port 3/0. So I'm gonna enter to serial 3/0 and then assign IP. You can see it's a 30.network, so I'm gonna assign IP 30.0.0.1, subnet mask 255.0.0.0, and then I'm gonna assign clock rate because this is, you can see this is the DC side of the cable, so I'm gonna assign clock rate and simply write no shutdown to turn on the port. So this is how you finish the configuration in router 1 as well. It is connected with only 2 ports, and then close it. Let's go to router 2 CLI mode. So router 2 is connected with serial port 3/0, config T, and you need to enter to the serial interface 3/0, and hence this is the DT side, so you don't need to assign any clock rate. So I'm going to assign only the IP address, and you can see this is the 30.network, so I'm going to assign 30.0.0.2 because 30.0.0.1 we already assigned for the DC side of the port. So I'm gonna assign 30.0.0.2 with subnet mask to 55.0.0.0, and then clock rate. No, we don't need to assign any clock rate here, so no shutdown. Exit, and let me enter to the int and serial port 2/0, and IP address will be 40.0.0.1 with subnet mask to 55.0.0.0, and here you need to assign the clock rate. Clock rate is 6400, and then no shutdown. This is how we finish router 2 configuration as well. Once you finish doing all the configuration, then the port will turn on and it will be green like this. So now let's go to router 0 and then add network to the RIP protocol. Enable, config, and then router RIP. If you are using router version 1, you just need to route router RIP, or if you want to use version 2, and in that case you need to write version 2 and then type enter. For now I'm gonna stick in version 1, that's why I'm not gonna type any version 2. Now after this you can add your network. So you can see router 0 is connected with 3 network, 10.network, 20.network, and 70.network. So I'm gonna add 10.0.0.0, and then another network I'm gonna add 20.network, and then another network I'm gonna add is 70.network, 70.0.0.0. So this is how you add network in the router in RIP protocol. So I'm gonna close this one, and let's go to router 1 and CLI command. Enable, config, and then you can see router 1 is connected with 2 network, 10.network and 30.network. So I'm gonna write router RIP and add 2 networks which are 10.0.0.0, 10.network, and another is 30.network. This is how I finish adding network to the router 1 as well. So similarly you can go to your second router and add 2 network, 30. and 40.network, and you can go to router 4 and add 3 network which are 40.network, 60.network, and 50.network. And then at last you can go to router 3 and add 2 network which is 20.network and 50.network. So once you finish doing all the configuration, you can go to PC and assign IP. I have already assigned IP. You can see it's a 70.network. That's why I have assigned 70.0.0.10 IP address to PC0, and then subnet marks to 55.0.0.0, and default gateway 70.0.0.1. So now close this and go to another PC and then IP config, and you can see it's a 60.network. So I have assigned 60.0.0.10 IP address and default subnet mark 60.0.0.1. So once you finish assigning IP to PC, then you can click your packet and you can send packet from PC0 to PC1. So it will show successful rate. If you click on simulation and click play on button, you can see the packet is traveling, how the packet is traveling. So you can see it's gonna choose route 2 because it have a less hop count. The packet is here. So this is how you do RIP protocol. Thanks for watching.